completed with the fifth chapter, that is indexing and hashing. So uh, within that we learned about different indexing methods and as well as static hashing methods, static as well as dynamic, and which are the ways through which we can go for implementing those concepts, and also seeing the differences between these two and in which conditions they are much more curable. So this we have studied regarding the fifth chapter, and now we are moving towards the sixth chapter in the syllabus. So the chapter name is transactions, and let me tell you that this is the most easy chapter of the syllabus, that complete database system, and considered as much more important also because this is the actual application of the database is there. So transactions, you might have heard this word previously also. So let me know, what do you understand by the transaction as per your understanding? What is mean by a transaction? So a transaction, it means that this is a sequence of steps performed in order to perform a single logical task. Okay, for example, if consider I wanted to recharge my cell phone. So okay, so recharging my cell phone, that is a my task, that is a single task. So in order to uh, that is recharge my mobile phone, so I will open any of the sites, just like just recharge it, or I may open any of the applications like Paytm, Google Pay, in order to recharge my cell phone. So in order to recharge, first I will enter my phone number, then will provide the bank details on the basis which account is linked, whether I wanted to perform payment by using account directly or by using debit card, etc. So here it means that the mode of payment selection, then on the basis of mode of payment selection, it will decide whether to go for OTP or not to go for OTP. Whenever it is related to any website, it will definitely ask me for the OTP. And then after if OTP is available, then I will enter that. Else it is not available for the Paytm, etc. Then I need not to worry about that. Directly putting the amount for which I wanted to, which package I wanted to buy, and then paying from the account. So it means that recharging a cell phone, this is my single logical task which involves multiple tasks. Adding the phone number, giving the OTP, giving the bank details, giving the package, and then the final will be the deduction from my account. And then the acknowledgement will come to my cell phone that yes, your mobile has been recharged with so and so amount. It means that recharging this single task will involve these many steps. If consider we skip either of the steps from that, we may consider that recharge may go to up to failure, or it may not be a successful transaction. So okay, transaction, it means that this is a single logical operation which cannot be divided further. It means I cannot do that today. Today I have entered my phone number. Tomorrow I will enter my bank details. Day after tomorrow I will go for entering the OTP, and day after tomorrow I will get a message. No, here this procedure is a single procedure. This has to be done in accordance, and that's why here I cannot divide these many, all the, it means a single recharge I cannot divide into number of operations. Yes, number of single simple tasks are available, but these all are performing a single logical task. Okay, so this is how a transaction is. So in terms of database, the same meaning we can apply to the transactions. And so which properties my transaction should have, when I can call this as a transaction, that we are going to study in this chapter. So at the start, I may say that this is a single logical operation on the database. That's why this is called as a transaction, which results into some output or some action. Okay. So let us go for the syllabus. So these are the syllabus points of this transaction concept, simple transaction model, storage structure, transaction atomicity and durability, transaction isolation, serializability, transaction isolation and atomicity, transaction isolation levels and implementation of isolation levels, and last, transaction as a SQL statements. So here you might say that there are, it means it seems like repetition of the same points. Here a complete chapter is based on the four properties, that is ACID properties of the database, ACID properties of the transaction, and how we can implement that and what is meaning by that. On that complete structure, we are having the chapter dependent. So let us start with the syllabus. So these are the few of the assignment questions. So already I think I have uploaded the fifth chapter also. So you can go through the assignment questions of the chapter 5 also. So these are the assignment questions. Few of the MCQs are there. So now let us start with the actual syllabus. Transaction concept. So now when it comes to the database, what is mean by a transaction? So a transaction is a unit of program execution that accesses and possibility updates various data items. Okay, so here a transaction, it means that here access of database is also done and may result into updation. That is where I am performing a read write operations on a multiple data items. Okay, in a transaction, it is not mandatory that only one data will be accessed. There are multiple databases might be involved, multiple tables might be involved, or multiple data members might be involved in the transaction, and hence it will go for updation, that is reading as well as writing operations on a database. So usually a transaction is initiated by a user program written in high level data manipulation language. Data manipulation refers to insert, update, delete commands, typically SQL or programming language. For example, C, C++, or Java with embedded database accesses in the JDBC or ODBC. So it means that whenever we are starting with a transaction, we may write some SQL query also, or we might write a program in the Java, that is database access program in the Java, and then access a database. Anyways, we can go for perform a transaction. So how to know whether when my transaction is started and when my transaction is finished? So there are two statements. Transaction is delimited by statements. Delimited means that within the start of this and end of this. This is the start of transaction and this is the end of transaction. Then I can say that these are the acting as delimiters. A transaction is delimited by statements or function calls of the form begin transaction and end transaction. So transaction consists of all operations executed between begin transaction and end transaction. So whatever steps we are going to perform, that all will be involved into these two statements only. So begin transaction, start of the transaction, and end transaction will be end of the transaction. So now let us come to the heart of this chapter, that is properties of the transactions. So these properties are called as the acid properties. So you might see that this first property starts with A, second C, I, and D. This acid, this is called as the acid property. So let us see these properties one by one. So A stands for the atomicity. So here, do not get this confused with the atomicity, AUTO. No, atomicity, it means that here atom stands for indivisible unit. So this term we have already studied into normalization. So atomicity, it means that a transaction should be either complete or none of the statements should be there. Okay, so for example, if consider I initiated with the recharge, and during the initialization of my recharge, I have entered OTP. Up to this point, my transaction is completed, and the deduction is also done from my um, bank account. But before performing the recharge, there got a transaction failure because because of any reason, server problem or any other problem. So in that case, I cannot say that that transaction was completed. It means that here the effect of my transaction should be before the recharge or after the recharge. Okay, it should not be in between the any of the state. So okay, so atomicity, it means that either all operations of transactions are completed, or those effects should be done on the database, or none of the statement effects should be done on my or reflect on my database. Partial results or partial operations should not be done in case of transactions. So atomicity, it means that transaction is a single unit. We cannot divide this into multiple parts. Yes, there are multiple operations, but all these operations are performing a single logical operation. Single, it means that it should be either 0 or it should be either 1. And hence, this is the main property, that is atomicity. Clear with this property? Clear with this property? Either reply yes, no. Okay,
Yeah, ma'am, it's clear. You can continue.
okay. So next is a consistency. Consistency, it means that here, whenever we are performing any database operations, so during the definition only we studied that this performs updations to a data item. So it should not happen that simultaneously two transactions or more than two transactions are performing updation on a database, and which results into inconsistent, that is incorrect state. Okay, for example, let us take an example of consider that account A is a joint account, that is between, let us take this account number as 111. This is the account number common between A and B. Okay, this is a joint account, and within that, right now current balance is at 10,000. Okay, so A is having some another card to access the. A is having other ways to access that account. B is having other ways to access the account. If considered simultaneously, both are reading the balance as 10,000. Now, A decided that it should perform a deposit of 2,000 cash into a database. Then, deposit, it means that addition of the value. So, this will update the value as yes, 12,000 is a new value. And when B has read 10,000, at that time B decided that I should withdraw 1,000 from the account. So withdrawal of 1,000. So I will take this as a some bold. Okay. So and because of this, the new balance will be written by B will be 9,000. Okay. So it means that here, as both are accessing the database, so can you imagine which state of a database is correct? Either first one or second one. Out of these two, which database state is correct? None of the state is correct, because here the database right now, as both are accessing this database, it should it should always keep a database in a consistent state. Consistency, it means that, sorry, consistency always stands for the correctness. Okay, am I clearly audible? Correctness, it means that here neither 12,000 is my correct value of a database, neither 9,000. Here correct value, I can say that this depends on a sequential operations. Wait for a minute. Here neither of the transaction is keeping my database into consistent state. So here I may allow A to first carry out the operation. So here in this point we are covering two properties. Isolation. Isolation, it means that whenever A is accessing a database and A is performing any update operation, which means some write operation is performed by the A, at that point B should not be allowed to access the same data member. Okay, if A is accessing the data and performing some update operation, then it should be isolated from the uh, another access. And so both, if both are performing a read operation, no problem, they can read the data members. But whenever either of them is performing a write operation, simultaneous access should not be allowed. That is, it should be isolated from that access. And whenever they are performing the changes, that changes should be given to this also, and hence my database should be in the consistent state, that it should give me the correct value. Okay, so this is meaning of isolation. So consistency, it means that here execution of a transaction in in isolation, that is with no other transaction executing concurrently, preserves the consistency of a database. So simultaneously I should be able to perform these operations correctly. And next one is a isolation. Even though multiple transactions may execute concurrently, the system guarantees that so then isolation. Even though multiple transactions may execute concurrently, the system guarantees that for every transaction Ti and Tj, it applies to Ti that either Tj finished execution before Ti started, or T just started execution after Ti finished. It means a sequential execution should be there. Thus, each transaction is unaware of other transactions executing concurrently in the system. And these are the isolation. It means that simultaneously, if both are accessing the same data members, changes done by one transaction should be given to the another transaction, and hence they may feel that these transactions are getting executed serially. Okay, and last property is a durability. Durability, it means that after a transaction completes successfully, the changes it has made to the database persist. It means even though there is some power failure or something else, still after restarting the system, we should be able to see the changes after the recovery from the failures. So these are the properties. Durability, it means that saving those changes permanently, and hence whenever if somebody is withdrawing the amount or adding the amount, that should be accessible to the next transaction. It should not be limited up to that transaction only. Okay, so any changes can be done to a data member, and those changes should be accessible permanently and hence available for the next transactions to read the updated data. And that's why this stands for the durability, the lasting of results for a longer period. Okay, so let me know if you are having doubt in this either of the four properties. Any property I should repeat? Okay, so here we are studying how the statements are written in a transaction. So this point is a simple transaction model. So here, whenever we are writing transaction, some syntaxes are changed. So we shall illustrate the transaction concept using a simple bank application consisting of several accounts and a set of transactions that access and update those accounts. So, okay. So here we are taking a banking application for explaining this concept. So let us see which are the two operations we always perform in a database. Read X. So read X, it means that this operation means reading a data item X. Okay, so this will not perform any write operations on a database. This simply reads a data item X, which transfers a data item X from a database to a variable, also called X, in a buffer in main memory belonging to the transaction that executed the read operation. So, okay, reading it means that whatever data item we are reading, a copy of that item will be copied into buffer and from buffer to the main memory. Wherever during executing the transaction, that member will be accessed. And write x, which transfers a value of variable x in the main memory buffer of a transaction that executed to write to the data item x in the database. So read x, reading from a database, and write x, it means that this is performing a write operation to a database. So here x may be changed to value, and we are writing the same data item to the database. So here this is a simple transaction for transferring $50 from account A to account B. So here this TI, it means a transaction name is given. So any transaction name we can assign. TI first reads a data item A. It reads a first data item A that is read into A. Then will deduct $50 from A and will store that data item that is changed value into A only and will write back the changed value. And the second operation we wanted to perform is transfer from A to account B. It means that 50 should be added to the B's account, and hence it will read a data item B, will add 50 to the B, and will write back the date value to the database. So, okay, here out of these statements, only write A and write B. These two are the operations which are actually performing updations on a database. So remaining all operations will be, it means all these operations will be done in a main memory, but write A and write B, this will have a effect on database. Okay, please read this transaction once. Understood with this transaction? Clear this transaction? Okay. Let us go to the next statement. So now check whether this transaction is also possessing the asset properties or whether these asset properties are followed by the transaction. So let us check for the consistency whether all operations are correct. So for this purpose, it means we may take a case that before transfer from 50 from account A to account B, whatever the sum of these two values are there, the same value it will be. It means same sum will be there after performing transactions. So I will explain this. What is mean by this first property, consistency. So here we are implementing atomicity, sorry, consistency. So consider that A is having the balance as 1000 and B is having the balance as 2000. Okay. So now if I am transferring from 50 to B, it means that 50 minus from here and 50 plus here. It means the summation of these two before the transaction should be equal to the summation of these two after the transaction. So consistency can be checked by this. Before the transaction, we are having the balance of A as to 1000 and B as 2000, and after the transaction, one is having the balance as 950. 1000 minus 50 will be 950 plus B's balance 2050. Okay, so now both will result into 3000. It means that I can say that consistency is achieved by this transaction. So here we check for the consistency. Yes, both operations are correct and there is no any doubt in the uh, following of consistency. Next comes the atomicity. Atomicity it means that first reading a data value A, then deducting 50, okay, then writing the new value. So A will be made as 950, okay, and then reading the B value, then adding 50 and writing B value equal to 2050. Okay, these are all transactions. Now consider that atomicity it means that out of these operations, consider that first three steps got completed successfully and remaining three steps remain to perform. Okay. Now in this case, if consider A's balance is right now 950, if we are having problem at this stage, okay, at this stage we are having the problem and transaction get completes at this position, then at this position B's value is also 2000. So it means that my database will not be in a consistent state or this is an incorrect value and here we are in loss of 50 rupees. So here, atomicity it means that either deduction and addition both should be done or none of the operation should be done. Either my database should be before in the state of before the transaction or either it should be in the state of after the transaction. Okay, that is meaning by atomicity. Okay, clear with these 2 points? How the current transaction follows these properties? Take a minute to read this. Next, durability. Durability once the execution of the transaction completes successfully. and the user initiates the transaction has been notified that the transfer of funds taken place. It must be the case that no system failure can result in loss of data corresponding to this transfer of funds. So, okay, whatever new values are there, that should be permanent. So durability can be ensured by, there are two ways. The first one, the updates carried out by transaction has been written to the disk before the transaction completes. This is one way that whenever we are performing the changes, we are writing the new values to the disk also. And information about the updates carried out by the transaction and returned to the disk is sufficient to enable the database to reconstruct the updates when database system is restarted after the failure. So here, whenever we are performing writing of these transactions to the disk, then there should be enough information to reconstruct the database. Okay, so this is a part of recovery system that is maintaining the durability. So in much more detail, we are having this into 8th chapter. Next, isolation. Isolation it means that simultaneous access of the same data members. Even if the consistency and atomicity properties are ensured for each transaction, if several transactions are executed concurrently, their operations may interleave in some undesirable way, resulting in an inconsistent state. So here it might happen that we started with more than one transaction simultaneously, and there is a overlapping of data items. Then in that case, it might happen that we may read the incorrect data and will result into some write operation. And so because of this, it should not be allowed. The isolation should be, it means the way this transaction manager works should be able to completely serialize those transactions and should be able to keep a database in a consistent state. So here, whenever a transaction is in the intermediate point, database may be in consistent state, that is inconsistent state. But after the completion of a transaction, database should be in a consistent state always. So if consider in between, before that withdrawal of amount from the 50 and before adding the amount to the B, it means deposit of funds. If we try to perform the summation of these two data items, 950 plus 2000, that will be incorrect. That is in between of the transaction, the database may be in inconsistent state also. Storage structures. So here, where a database should be stored and which are the different types of the storage structure available for the database. So in this point, we are learning this. So the first one is the volatile storage. So volatile storage it means that as soon as the power goes off, the contents of that storage will be removed or will not be last long. Okay, so as soon as up to the power only that contents remains there. And whenever there is no power, the contents will not be available to that that storage. So information residing in the volatile storage does not usually survive system crashes. Examples of such storage are main memory or cache memory, etc. Main memory, for example, consider right now I open my laptop and there I open two files. Okay, consider Word document and a paint file I open, and I am writing something as well as I have drawn a picture also. So if consider because of some any reason that my machine got shut down, and if I restart my machine any after any interval of time, at that point I cannot see that those two applications were in which state. Okay, it automatically doesn't start those applications. So in order to start those applications, we should start those applications, open those files, and then only right now the recovery systems are available, which will ask me whether the last state you wanted to load, etc. Okay, but the main thing is that whatever my main memory is there, whenever we are opening any application, that will be loaded into main memory, and then only that application can be opened. Otherwise, that application cannot be opened automatically, and hence main memory is the example of a volatile storage. And cache memory is also an example of a volatile storage. Next structure is a non-volatile storage. Non-volatile storage survives the system crashes, and hence even though there are some system crashes, still it preserves our data. For example, our secondary memory or hard disk, where we keep our data, that can be accessible even though there is any power failure or any repair or etc. Okay. And last one is a stable storage. So stable storage, it means that the storage structure which doesn't lose data at any point of time. Okay, so stable storage, it means that the storage structure which doesn't lose our data, or data within a stable storage never lost. So information residing in a stable storage is never lost. Although the stable storage is theoretically impossible because there is no any memory which cannot, it means which can survive all the possibilities. Okay, even though it means that if I decided that whatever the memory is there, that memory also got some physical damage, then we cannot, it means we cannot guarantee that that data will be also preserved. Because here, if any software related problem etc. are there, then we can cure. But if the chip or memory itself got damaged physically, then we might consider that there is no way to recover that data. And hence, here a stable storage refers to a storage structure which preserves the data in any case. It means all the cases. And hence implementing such memory is theoretically not possible. So, but there are ways through which we can implement this storage structure by repeating a data or by fragmenting a data. There are a number of ways through which we can go for a stable storage. So next point, transaction atomicity and durability. So here, whenever there are incomplete transactions are there, those incomplete transactions will be called as a transactions aborted. That is, to not reach to the success level or to not reach to the end transaction. Read this slide for a minute. So, uh, those transactions which are completed, those transactions will be called as a committed transaction, and those which could not reach to the end stage, those transactions will be called as a aborted or forceful termination of a transaction is called. So once changes by the aborted transactions have been undone, it means it might happen that whenever I have written write B, those changes might be done to a database also. And hence, whenever we are undoing those operations, we may say that the transaction is being rolled back. I'm facing some gate problem, so we will stop the lecture today here only. Please, all of you, enter your roll numbers in our attendance chat window. We will close our lecture here.